How does Delph?
Good. So I'm Adam Leventhal. I'm the CTO here at Delphix. Before that, I was at Sun working with Matt, and then worked on Fishworks, the ZFS storage appliance, as it's now called.
And you created dtrace.
And I created dtrace, so I'm wearing this dtrace t-shirt to a ZFS conference. So what does Delphix do? So it's easiest to talk about the problem that Delphix solves and kind of wend my way down into ZFS. So Delphix solves this problem that lots of big companies have. They have monstrous databases, and for every big production database, they have many, many copies in non-production use cases. And so developers and testers and QA folks and reporting and analytics and backup and production support, all of these people need copies of the production database. Those copies are a pain in the neck to create, they take a long time to create, they take up a lot of space, people deal with stale copies and so forth. So what we do at Delphix is we virtualize at the database tier, so we make it very cheap and very easy and very efficient to create copies of databases. Everyone, that clear enough? Okay, cool. And what that does is it means people can run their projects faster and make their developers happier and trim time on their dev cycles and stuff like that. So that gets down to now kind of explaining from the ZFS perspective. ZFS, I joined Delphix in about 3 years ago in September 2010. Matt and George joined me about 2 months later. But the choice to use ZFS has actually been made long before any of us had showed up at Delphix. Delphix chose ZFS as a platform in 2008 because they wanted a file system that was foremost reliable, had writable snapshots and clones, and was freely available. And I think open source was kind of at the back of the mind as well. So that's why ZFS was chosen. And what we do with ZFS specifically is, first we've made a lot of extensions on top of that, and I think Matt will want to talk about some of those. But we make heavy use of snapshots and clones, heavy use of snapshots and clones, much more so than we had at Sun or at Fishworks or at Oracle and any of these other places. So each virtual database starts from a snapshot of what we call a source, and we create a clone, writable snapshot, and then are able to provision that to some point in time database instance. Matt, how do you do?
That's good.
All right, I think. And then do you want to talk about some stuff we've layered on with ZFS?
I was going to, I'll talk about maybe a few things that are forthcoming that we've done a lot of enhancements in ZFS, like the write throttle that I think a lot of you have heard about. But I wanted to mention a few things that haven't been pushed into Lumos yet that are on their way. So one is ZFS bookmarks. So not to be confused with the internal data structure called something or other bookmark in ZFS, but this is basically a mechanism that's specifically for doing a ZFS send from a place where a snapshot used to be but no longer exists. So the idea is like if you're doing remote replication, you're continually like create a snapshot and then send from the previous version, from the previous snapshot to the new snapshot over to the remote system. So you always have to have that previous snapshot on the sending system. ZFS bookmarks allows you to create a bookmark at the point in time where that snapshot represents, and then delete the snapshot, and then send from the bookmark instead. So you don't, if you're doing remote replication now, you don't have to have any snapshot that like always exists and is tying down storage on the sending system.
Other stuff we've done, Chris and Basil Crow worked on the feature flags, which I know a lot of folks are using because it's important for us to enable the whole community to build different parts of ZFS out without being usually incompatible in tough ways.
So another thing that I've worked on recently is the zero block compression or embedded data feature, which is going to be going to Lumos even after we get through our backlog. But the idea is basically that some data blocks compress really, really, really well, and they can actually fit down into like about 100 bytes. Then we can put that data into the block pointer itself. So the block pointer doesn't actually point to the data block, it actually contains the data And this helps a lot for like small bits of metadata. So we think this will probably improve like ZFS list and things like that because all those properties are stored in like a different object with a different block, and instead it'll just be one less random I/O because you'll already have the data. It's also very advantageous for our particular use case where initialized but otherwise unused Oracle blocks are very common. So one thing that DBAs like to do to benchmark their storage subsystems is to create an empty table, which tells Oracle to go write, initialize every block of that file with a little header and footer that goes on it. Well, it turns out that that header and footer can be compressed with LZ4 to fit into 100 bytes. So it super accelerates that, benchmark special, but it also makes it a lot faster to like read that data because we already have the data in the block pointer rather than having to go through disk.
Do you still keep the block?
What do you mean?
You say you keep the data in the pointer?
Yeah.
The actual data block?
No, because we don't need the data block. We have the data.
So the whole thing about having the data block and checksum in different place.
So the data, like the block pointer, so the block pointer is always checksummed by the block that points to it. So for example, you have an indirect block. That indirect block is verified to be correct because the block pointer that points to it has its checksum in it.
Right.
So if we're putting pointers to data in there, those pointers are verified to be correct. If we're putting compressed data in it, that data is also verified to be correct by the pointer that points to it.
Is the D node going to have information that the block pointer itself contains the data?
There's like a new bit in the block pointer that identifies these
Okay, so you're not
block
using
pointers
all-
that have.
You're not using the entire block pointer. There's some stuff like those.
Yes, yeah. So there's still like a birth time and then a props word are still used more or less the way that they are.
We should give ourselves a hook and make someone else listen.
All right.
Okay.
You're in the front row. Do you want to go next?
Sure. I like this one. Hi, I'm Bart Mustaki. I'm at Joyent. We're basically a cloud provider. So we use ZFS in a few different ways. Primarily, first off, just for taking around images and dealing with the fact that customers have VMs. Every VM gets its own ZFS data set, whether it's an OS-based virtualization or you're using hardware virtualization. If it's hardware virtualization, you get ZVols. And those are what turn into your disks. Those images need to be moved around, so that's all through snapshots and clones, very similar to what Delphix is doing. In addition to that, we've done a bunch of enhancements in ZFS multi-around multi-tenancy for dealing with basically enhancing the I/O throttle to be more container aware, so you can basically define shares on that, so you can basically have a better sense of fair I/O sharing. Stuff that we have in the works, which is kind of interesting, is FS limits. So basically, you can do limits on the number of snapshots and data sets, because if you're aware, you put 10,000 snapshots on your box and things get very sad right away for that machine. And the last thing you want is one bad actor to screw over everyone else. The other big thing we do with CFS is basically the core of our new basically object storage and compute service. And what happens is basically it's an S3-like data store, but you can run compute directly on there. So basically spin up zones, go do whatever compute you have all your packages that you ever want. Then once that's done, you roll back the zone and move on to the next customer. So that's already a pretty big use case, and we're using rollback probably. You have like hundreds of rollbacks going on per second sometimes. So.
Cool. All right.
So do you use the resource management at all?
What do you mean?
Sorry, like CPU, memory.
Oh yeah, that's all.
So have you guys done anything on the I/O?
Yes, that's exactly what I was talking about. We have our own I/O.
Integrate with the GLP.
Yep. It's all zone aware or container aware, basically I/O throttle.
Cool. Do you want to designate someone from Nexenta to?
Well, I guess
We heard a little bit, but maybe
Yes, I
just
guess I can-
a higher level overview of what Nexenta does and like what
Yes.
what you sell.
Yes, very quickly, as you already know, from Boris's talk, Nexenta basically have a storage appliance based on ZFS. So we basically use every single feature of ZFS, right, from snapshot. So we basically use ZFS as the backend for NAS and SAN protocol, right? NFS, SIP, iSCSI, fiber channel kind of thing. So we at Accenture itself, we try to work on failover performance, ZFS performance kind of things. We also spend a lot of time working on the ComStar framework inside of Illumos.
What's ComStar for people that are not from the Illumos
The
community?
ComStar is stands for Common
SCSI target.
Common Target framework, and it basically allows us to do fiber channel block protocol. We basically export ZVOLs as fiber channel and iSCSIs. Let me see what else. A lot of the work that we do inside of the company actually are on driver work, SIFs development kind of things, networking fixes and such. We inherit a lot of stuff from the ZFS community, and we try to push back as much as we can.
Thanks.
Yeah, I just wanted to add that our customers like to push our systems to the limit, so we run into a lot of performance issues and concerns that you might be talking about lately.
Yes.
So, and overall, like I mentioned, it's a general purpose software defined systems with used in mission critical application, etc. So this is always a must and performance is very important.
You guys are mainly selling software and partnering with people that bundle that with hardware, right?
Yes.
So true, right?
Yes.
The example is software-defined storage, meaning that the storage we can we run on different platforms, different systems. Obviously, there is a hardware compatibility list, and we run a pretty extensive certification process to certify different platforms. So to help our customers get the best out of the process.
Thanks. I don't know where you.
I'm not curious, but honestly I joined very recently. I don't know how much.
Is there any?
So I'm
you wanna?
So Pluribus Networks, what they essentially do is we pick up the regular switch code, and that's hooked up with a x86 code. So you essentially have an OS running which can program the
Network switch.
network switch. And in addition to that, since you're doing the SDN provisioning, most of it is essentially zones and virtual machines, like what Robert mentioned on provisioning. So you essentially have VMs and either a KVM running the machine. So that's where ZFS is right now being used, where you either put an ISO image to provision it for the various VMs, or you put a zone image on it. So that's where it's being used.
Cool. What OS are you guys running on?
That's again Solaris. It's called the BN NetWiser, but yeah,
It's Illumos based.
it's Illumos. It's not Illumos yet.
Oh, okay.
Yes,
Solaris?
it's still a very old build of. It's probably off 134 with some fixes pulled and cherry picked. So we will need to.
Cool. Thanks. You wanna?
But I guess some fixes, important fixes, have been pulled in now. Which of those, even I'm the same as Rafael is fairly new to this, but then yeah.
Okay. Cool. Thanks.
I can just set up with my laptop. I don't have to slideshow.
Yeah. Oh,
I'm just gonna
yeah, sure.
I'm Steve Burgess. I'm with Datto Incorporated. We're from Norwalk, Connecticut. I'm the Git master, the ZFS understander, and development operations engineer. So we're a Linux company, generally Ubuntu. Our main product is unfortunately written in PHP, but we are working in a lot of the different languages there. So we are using the ZFS on Linux kernel module provided by LL. So that brings me to the point of help number one. We want to talk about libzfs, how we can integrate with that, how we can stop using the command line. Command line is so good and it is so well documented that we are now dependent on it and use it all the time. So thanks for that. But definitely a programmatic way of getting in there and helping the developers who don't understand the internals of ZFS safely get at the things that they want to get at is one of the things that I've been working on recently. Because we had a whole bunch of ZFS list pipe to grab, and that was great. So we operate our own cloud, and we also operate lots of machines out in the field, and we run OpenZFS on all that. Let's see.
Oh, the cloud in the field. I like it.
You guys are missing out. So our cloud is about 1,000 servers with over 50 petabytes of data. I know we have more than 1,000, so if anybody from Data watches this, I don't know what the number is, it's more than 1,000. And these are very hot storage devices. They're not cold at all, so we are virtualizing all the time. One of the things that we actually do is just like the Delphix pre-provisioning. We start up these virtual machines in the cloud to let the customer know that whenever they want to come get their data, it's good. So we're constantly starting these things up, and they need about as much RAM as they would have needed to start up anyways. So we have a whole bunch of RAM going to ZFS, and then these guys are constantly taking. Then the next thing, I'm missing out on some of the pictures I should have just done.
Yeah, you just put it.
I should have just done it, I'm sorry. Is it gonna warm up?
Yeah.
I mean, it's some really killer stuff here, people. I can go into while it warms up. One of the cool applications that I've done that was not exactly for work was we had a Linux kernel thing that was working in 3.5. No, that was not working in 3.5 and was working in Linux 3.6. And so they asked the question, how can we get to that? And so I did a Linux kernel reverse bisect, essentially.
I think you might need to change which or mirror your display.
So if I can, where's the think it is? There it is. All right, this is gonna work out just great. Let me tell you. All right, so we got 1,000 servers, 50 petabytes, and it's hot. So just like Delphix pre-provisioning, we are starting those VMs all the time. But as you can imagine, when disaster comes for their multiple boxes, they want to start up all those VMs and actually run them, not just a pre-provision, does this thing work? So again, we've got lots of RAM going to ZFS, and then when something comes for your 6 devices there, you got to start them all up. So the talk today about VM integration with memory management is definitely interesting to us. Integrate with the Linux page cache, dropping it more. I know ZFS on Linux got a lot better on that in 6.2, and can only go up from here, right? So sometimes we're putting out new servers just about as fast as we can, but due to us being a business and wanting to make money, we of course try to get as much out of the old one as we can. So that means we've got these pools getting up to 85% full, and those are actual customer chains. We can't break those out and just put them other places. So we do have to actually make a transfer, and that's really expensive on our end, on that guy over there. So that multi-tiered storage sounds interesting to us, with maybe getting the SSDs on these guys so that they can ingest it faster. Anything we can do like that. I think I have a help point 3, improve send receive speed. We're probably doing something wrong. There's probably some configurations that we can do better. There's also things that maybe we can help you guys give back to the community a little bit and fix some of that stuff. I know there's a buffered send receive talk on the chalkboard for today, so that'll be great. So here's what our basic product does out in the field, because that was our cloud. So these are our guys out here. They, when the computers want to back up, we expose over the network a block device for them to write to. They write what's changed since then. We close it up, take a ZFS snapshot, and then send that one to the cloud. But since that first snapshot that you actually do as a block writing from your devices is way more gigabytes and up to a terabyte of stuff that you don't want going over your network, we actually round trip them. So we take hard drives, put them together, mail them to you, make a Z pool on that, ZFS send onto it, mail it back to the data center, and upload it directly to the cloud. And during that time, you're building more snapshots, and you send them all at the end. Works pretty well. Cool uses. I guess this is another one of the things that I did off of our devices. I back up our GitHub instance. I'm the proprietor of our GitHub Enterprise within the office. It's a real game changer, I think, that you guys have had experience with if you're using the ZFS and you're used to using it, to go into a directory and just have the files there and then have the snapshots be available to you through a ZFS list and that kind of stuff, as opposed to cluttering it up with files all over the place. It definitely changes the way you think about how backups can work and how you can store data, and really cleans that thing up, I think. And then the other cool thing I did was that Linux kernel reverse bisect. Didn't get into too much. So we set up a machine basically with a clone of the Linux kernel line and a script that tested whether or not it worked. So then you compile the new Linux kernel, run the test, 0 or 1, so you make a new virtual machine exactly off of that model, ZFS clone again from the first one, give it the new shot, it builds that, tests it, and goes back. And without ZFS, that whole thing would have been a lot more expensive to clone out again. And not only the running Linux operating system, but the clone of the entire Linux repository, because you never know where in there you're going to get. So in 13 steps and really quick, we had ourselves the answer for which patch fixed that change, and we were able to look at it and see why the Linux kernel was hanging. That's about it, I think. The other cool one. Yep. All right. So that's what Netter does.
Thanks. Any questions for? Cool. Next slide. You guys are both from Delphix, you're from Pluribus, you're from Hooters.
No, volunteers.
Nope. Cool.
Hi, my name is John Lehman. I'm from Sage Cloud. I'm in Boston. We're using ZFS on Linux for our cold storage product, which just went to beta a couple of weeks ago. Cold storage is another term for archive. The idea being is we're targeting large businesses who have lots of data with petabytes to store. And rather than just storing that data, sticking it in the vault, you don't know if it's going to be good when you need it in 5 years. We're targeting ZFS file systems so they can write the data to it. The data can be scrubbed periodically. And if there's a problem with it, the operators can go in and switch out a disk. And the people involved can know that their data is safe. Some of the challenges we're running into is being a archive. We're pretty much going to write once and hopefully never read unless disaster strikes. But we'd like to power down some of the disks because there's no point in having thousands of disks spinning. And the problem we're running into is powering down disks out from under ZFS isn't so wise. There's all sorts of issues there. So we're trying to find a better solution for powering down disks. Whether that be part of ZFS or maybe some external utility. We're not sure yet. And another thing we'd like to see is better API support on some of the commands, like for instance, zpool status, instead of having to go through main with argv, argc. It would be nice if we had some API calls that we can make to get zpool status. I think import's another one that doesn't have a really API. If you go through argv, argc, what's happening is if you get an error, something spits to the screen, it's very hard to parse that. We'd rather catch it programmatically and take action there. Nutshell.
Thanks.
And actually, I was going to say the stuff that Boris was talking about with the storage tiering could help your power on, power off problem. Because if you had metadata in power on storage, you could power off data that is sitting on disks that you potentially wouldn't read.
Yeah, that'd be cool.
That might be another use case. Right?
Oh, that's so interesting. Yeah, I can do that. That's right.
We'll talk. All right. Thanks.
Next volunteer.
It would be helpful if you stand in the front. Those great for better video if I'm not shooting over everybody's heads. Thank you.
So I'm Justin Gibbs. I work at Spectral Logic. Spectral Logic's gone through several different product iterations using ZFS. Some of the most interesting changes that we've made are actually based on a product that we're not working on anymore. But they're very interesting probably for people who have overwrite scenarios like you're using zvols and stuff like that, or iSCSI, for instance, out of zvols. So the main crux of those changes is to do asynchronous resolution of copy on write faults. So you come in and you do an overwrite. If you grab a block of data, we basically will allow you to make that update in memory and return to the writer and let them write additional data while in the background pulling in the read in order to fill in the bits of that block. So the performance improvement in several different workloads was sometimes, order of magnitude faster, just because the writer could progress and give us more data, especially if you have scenarios where the writer is sequential. So the way ZFS works right now, you come in, you touch a block, you immediately resolve that block. You pull it from media because you know it's an overwrite. But if the writer's just going to
overwrite.
Yeah, it's partial overwrite, yeah. But I mean, even if you start at the beginning of a block, it's gonna. Oh yeah, I mean, if ZFS doesn't know that you're going to write the whole block, right? Yes. So let's say your record size is 128K and you're writing 8K at a time. ZFS will just go and fetch that thing, even though you might be writing a whole stream of sequential 8K things. Like for instance, maybe your VM is NTFS with a nice 8K native record size, right? But you really want to use 128K records on your backing store just to make the metadata more efficient and things like that. So we're working on getting that stuff upstreamed. Hopefully we'll get it there at some point. So on our current product that we're working on, we're also an archive company, but usually dealing with powered off storage. So tape, potentially shingled media at some point, not really sure. But that there's always an asynchronous recovery process required. Like you might, let's say that it's a Facebook or maybe it's a yearbook company or something like that. You might have thumbnails that are in hot storage for all the pictures that you want. You could select them and say, I would like the full res copies. We'll go off to tape at some point and bring those back. So there's an asynchronous recovery process involved. But the current products that we're working on are basically serving as a cache tier to go to that cold storage. And the other aspect of how we're trying to do this is to tie it all into the web interfaces that people are familiar with now. So that's S3, and we actually have a version of S3 called DS3, Deep S3, which works in batches. So you can basically tell the system, I've got this 10,000 object bolus of work that I would like to stick in cold storage. We get that request as one request instead of 10,000 individual requests. We can then figure out how to schedule that properly with the robots and the tapes and all of that kind of stuff to be really efficient, and then stream it through our cache. To make that transition even easier for folks that aren't familiar with S3 or DS3, or maybe they have a giant NAS archive and they just want to be able to drag and drop files over there, we're also looking at adding a NAS cache in front of the tape storage. So essentially, as a researcher, let's say at a laboratory, I may know that this particular data set I'm not going to touch for 3 years. So the actual consumer of the data can make the decision to drag that thing to deep storage, and also can go look at our system and see it to drag it back. But by making it NAS, any client, any operating system client that can talk to NAS can make that data movement without having to have any middleware or anything else in order to make that data movement possible. And then we make sure that the data is stable, so we create a version of the data, and then we push it out to tape. So our main need in the near term is the ability to create that stable version of individual files. And so that's ref links or something like that. The main reason why snapshots don't quite work for us in that environment is that we want to be able to allow the end user to say, yeah, that data set I no longer need anymore. I would like to be able to individually pick different objects in the data store and blow them away. But with something like ref links, where it's an immutable hard link, we could provide S3 versions of objects in a very seamless way, just using the copy and write semantics of ZFS.
Cool. I remember a talk from Special Logic a while ago about performance improvements they had done, and comments in the code. I remember that seemed pretty exciting. You guys were saying you're going to get it back in.
Yeah, we're working on it.
Okay, cool. Was that what you were talking about earlier in the talk?
Yes,
okay.
yes, absolutely.
Yeah, that looked really, the comments are always great.
Yeah.
And those who know FreeBSD first, and then...
It's actually not in FreeBSD yet either. We've tried to follow the process of we need to get it into a Lumos and have a Lumos people review it before we push it into FreeBSD. But it's been in a shipping product for over a year now, and gosh, we probably developed it 2 years ago, so it seems pretty stable.
Have you guys looked into like CSS changes with shingle media?
We have thought about them for like half an hour.
Okay.
But I did actually attend a seminar about shingle media, and so I understand a little bit about it and some of the challenges. Fragmentation is interesting, but maybe with some changes in the Metaslab code, you might be able to make it work.
Yeah.
I mean, it sounds like they're kind of gravitating towards like 128 megabyte zones or regions or whatever they call it, and so maybe a Metaslab per zone. Or, I don't know.
Yeah, I'm sure there's some interesting stuff to do.
Yeah.
Thanks, Justin.
Yep.
Next volunteer. Yeah, go ahead.
Hang on.
Can you go up to the
And while you're coming up here, I'll change the tape.
Hi, I'm Alfred Perlstein. I'm with IX Systems. We do FreeNAS and TrueNAS. So we are a open source network attached storage, and we're sharing ZFS over NFS, CIFS, AFP, and also doing iSCSI. Most of our work has been integration with FreeBSD and getting ZFS running well on FreeBSD. And ZFS has been pretty awesome for us. We're actually able to, well, with our 10,000 downloads, we're actually able to collect the metrics on the FreeBSD kernel and debug problems pre-FreeBSD major release, sort of by seeding the OS out to all the downloads that we get. We're looking towards more contributions towards ZFS right now, but mostly it's been performance on FreeBSD and getting stability. So I also have a couple of USB keys in my bag, and wants a copy of FreeNAS for the phone. Yeah, that's it.
Yeah, very cool. Who's next? Yeah.
So my name is Alex, and I'm actually a hardware guy. And so what we've done is we've done a hardware accelerator for SHA-256 that is very easily pluggable into ZFS. We already have a patch for ZFS on Linux, and it works great. So it looks like a lot of people are using SHA-256 for checksumming and for data integrity. And what I heard is that it is often a bottleneck for performance, especially if you're trying to do many disks or flash storage and things like that. So basically we have this relatively low-cost hardware accelerator, works with ZFS on Linux. We are working on Illumis patch. Again, it should be fairly straightforward, designed specifically to be high throughput, low latency, very low overhead on the software side. If there are questions or any interest, I actually have some.
It's a PCI card?
Yeah.
Can you show it to us?
Sure.
Just, it's always fun to see hardware.
Christian, can you go next because you're also on hardware?
Sure. Yeah. Do you have any fun hardware to show us?
Yeah, it looks like this. It's just basically a PGA board, but the know-how is how to create the device, software hardware interface, and also very low latency, high throughput implementation.
And what's the throughput?
With this card, you can get 2 gigabytes. Yeah. Again, this is more limitation of PCI on this card. Fundamentally, we can do whatever we want. It's not a big deal. And on software side, to give you perspective, like we have 2 sockets, Sandy Bridge server. So with 2 SSDs, we get about 800 megabyte throughput. If we run SHA-256 in software, we utilize around 80% of CPU just on SHA. With this, the CPU utilization falls to like below 5%. So
cool, very cool.
Did you say it's ASIC or FPGA?
It's FPGA. But yeah, so again, if there is interest, we can discuss.
Christian.
Lucky I have it right.
Yeah. Well, if they're showing their hardware, you gotta show yours.
Hi, my name is Chris George of DDR Drive. I'm the founder and CTO. I'm I guess also a hardware guy, but stretched enough to write the Solaris driver. Our product's called the DDR Drive X1. Basically, we marry the speed, performance, and reliability of DRAM with the non-volatility of SLC flash. We're very close to formally introducing, so we've had that product for a couple of years. Our driver came out in January of 2010. And when it required external AC/DC adapter for the power backup. And we're kind of excited to have a supercapacitor solution which enables us to remove the external power, which for a lot of customers obviously was a real pain. So we're kind of excited about the supercap. It's taken us quite a bit of time, and one of the reasons is that we're actually going to offer a 5-year warranty so that you can really install it with the card and then forget about it. And that longevity aspect was a key design challenge. So we're We exclusively target Zill acceleration, which I think we have to be the only SSD vendor to do that. So we're all in on ZFS. So, we support all your efforts, and
Cool.
we love ZFS.
Thanks. Any questions for Chris before you? All right. Cool, thanks. Oh, sorry, I didn't see your hand.
Quick question about the size. What are the sizes of this media?
Yeah, our current is 4 gigabyte. Our next generation will be 8 gigabyte.
Thank you.
Next, you want to go next, Brian?
I don't think of myself as a vendor. I come from a national lab, and we actually aren't selling anything. We did the original port to ZFS on Linux, mainly because we needed it. So we run supercomputers that are all Linux-based, and we need storage for them. So since we're a scientific computing center, we care a lot about the fact that the data is right. So previously we invested in hardware solutions for this that did checksum on read and stuff like that. But upon looking around, that was not the way to go. So we made an investment in pulling ZFS over to Linux so we could use it there and get the data integrity protections. All the other good stuff that came along with ZFS, that was just gravy from our point of view. But the real reason was data integrity and scalability, I suppose. So I guess I don't have anything else.
Biggest supercomputer in the world. Biggest ZFS.
Yes.
Thanks for letting me gloss over the details.
But if you have a question.
So you guys use a distributed file system over ZFS, right? So each machine has ZFS on it. You say in some of the slides and stuff that you produced before that snapshots do help you guys. I just can't really wrap my mind around it. If you snapshot on this machine, because you say for like looking back at what happened in error correction, what do you do with one machine out of 70 that were...
So we don't take distributed snapshots today. We could, but that would require us to coordinate across the whole distributed file system, right? Well, which we'd like to do. It'd be a nice feature for Lustre to take distributed snapshotting. So that's certainly a cool thing we'd like to do. I think the more useful use case for us is something like upgrades. When we need to take the whole file system down and do a major software update to it, particularly on the Lustre side, right? We can take a snapshot before we do the update, and if something goes horribly, horribly wrong, which unfortunately isn't unprecedented, right? We have a way to pretend that never happened and roll everybody back to the pre-upgrade situation.
All the guys go back to...
Yeah. You know, we can bring it up, everybody can like out the file system, we can run for a couple hours and say, oh my goodness, what has just happened, right? And then go back.
So you kind of stop Lustre before that snapshot thing? You say, like, okay, Lustre, stop right
Yeah, so it's a distributed snapshot but done manually, basically. It's more of an administrative procedure. It would be nice to be able to like coordinate that through Lustre, but short of that, it's a nice administrative tool for us. But the bigger win for us is actually compression. Worked out great for us. Turns out our data on our data sets we didn't know, very compressible. So, so we got a nice performance boost out of that. So that was cool. Cool.
Do you do anything for HA? Or for the, I believe it's called storage now, the storage servers? And,
We do. So Lustre supports failover, basically. It's just basically active failover for the servers. If one fails, we just start ZFS and port it on the other server node, basically, and then basically start Lustre there, and it will pick up the services for a failover partner. So there is some concern there about importing the pool in a failure scenario and accidentally trashing it. That's kind of a worst case for us. So we do have higher level scripts that coordinate the failover process in an automated way to make sure we don't accidentally import the pool on both nodes at the same time and completely trash it. So we would like to do some more work in that area too, because I think there's room for improvement in ZFS about coordinating that and maybe allowing it to detect the fact that it's been imported on both pools concurrently, quickly, and prevent it. There's some papers out there for ways to do that, all right, and some write-ups, but they haven't been implemented yet. It'd be a nice feature.
So are there particular things in your implementation of ZFS that make it possible to be an OSD, or could another ZFS appliance and another operating system be an OSD in your environment?
So OSD in the term of Lustre's OSD. So it's all, Lustre ties directly into the DMU for ZFS. We haven't changed the implementation for the DMU much. It uses the standard interface. So we have extended it in a couple of ways, but I think those changes have been made back into Illumos, like transaction commit callbacks were added to Lustre. I believe those are in Illumos.
Way back in the day.
Yeah. But by and large, I think the basic functionality you need is there. There may be some performance improvements in certain areas that we take advantage of in Lustre, like storing extended attributes as a system attribute. That was important for us to improve performance, right? Because Lustre makes heavy use of extended attributes, and that's not exactly ZFS's best workload at the moment. So we've been doing some work to improve that.
Cool. Thanks. Who is next? Anyone? Jorgen? Anyone? Nobody else wants to talk about there? Okay, I guess a lot of us are from the same companies.
I can tell you what we do. I'm not sure it's interesting.
Is it related to ZFS?
Yeah, sure.
All right.
But we don't do improvements, we just consume it all.
Sure, yeah.
Okay.
Do you mind?
Great. I'm Jorgen Lum. I work for GMO Internet in Tokyo. We're a medium, large ISP, internet service provider. We're a group of ISPs. We have quite a few now. We have something like 5 data centers in Tokyo. So we have a lot of storage. We use basically ZFS on NFS servers. We have lots of them for customer data. So the customers might not benefit from ZFS, but we do as administrators in terms of backup and just being able to provision commands. So we do simple hosting from just email, FTP, or web, all the way up to VMs if you want to run your own OS or whatever kind you want, basically, and that's all on top of ZFS. We try to do everything real time, so if you want to create a new email account, then it gets provisioned right away, and ZFS takes care of the back-end stuff, which is quite nice. We were originally all Sun, Solaris, so we started with ZFS in 2008, I think, because we were tired of doing metadisk mirroring. So getting full mirroring was quite a nice win. But of course now we got to decide where we're going to go, because we can't stay with Oracle after their new process. Just wasn't cost effective anymore.
So you're actually still using Oracle ZFS now?
We're on the edge of having to be forced over there to make a decision. So either it's Open Indiana, we might go with Omni, we could go with Linux or one of the others. We're quite open, so we're kind of shopping around a bit. Not too sure what we're going to do, but staying with Oracle hasn't been an option. I apologize for those who like Oracle.
Probably not.
Yeah, so I guess that pretty much sums it up.
Cool. Thank you.
Basically, it's one thing we want to change. It might seem a bit mean, but when you have quotas, you have compression. At the moment, that benefits the customer, and we'd like to change it to benefit us.
That's going to be very hard.
Do you think?
Yeah, we serve that the hard way. The problem is that you don't get the updated data is done asynchronously. So the size updated for the compressed data is not done in situ. So we love it too.
Yeah. That would be okay.
Cool.
Good. Thank you.
Anyone else? Otherwise, we'll move on to the next sessions. All right. So I think, is Karyn, are you there? Yes. Should we do the community organization? So I think we'll do community organization stuff, then channel program stuff, and then we'll see if maybe it's time for a break, and then we'll then maybe Adam will tell us about performance. which is on the other screen.
Sorry, I'm running all kinds of. So I thought it would just be good to have a discussion about what we need out of the community going forward.
Can you introduce yourself?
Karyn Ritter. I work at Delphix, and I've just been helping out a little bit with the OpenZFS stuff.
We have Karyn to thank for all the stuff that's been organized for us today, all the food and the chairs.
It's mostly Ann Togasaki in the back who did all the work. So, we started off just kind of with this idea of having this community. We got a bunch of people together, and they very generously gave their time to try to think of what we should do around the launch, the kind of content we should have, the kinds of things that we should be working on. And that's kind of how we've been managing it. It's a little bit ad hoc. People are just updating the website, which is all great. And I think we definitely want to continue with that. We've got the mailing list. We've just got basically that one for now. Although I think the Linux mailing list will someday maybe move to OpenZFS as well. And then we've got the Dev Summit that we did. But that's pretty much all we've done as a community in OpenZFS. I know all of you guys have been working on stuff for a long time.
Can I ask a question?
Sure.
So the ZFS on Linux group, we'll get a lot of things like this doesn't work on this version of Gentoo and that kind of stuff. I don't think you'd want that on developers.
Oh, no, we don't. This is just that they've outgrown Google.
This is just hosting.
This is just hosting.
Oh, it's going to be different. Right?
Yeah.
It just on certain days we've outgrown how many messages Google Groups will pass for us. I think it's like before 30,000 messages a day or something like that. And sometimes we exceed that and things bounce.
Yeah.
So we'd like that not to happen.
Right. And so we have this mailman setup, which the hybrid cluster folks have very generously hosted and actually did all the website design, which has been great. And they said that they'll move the mailing list over.
So this is just like providing infrastructure for it.
As soon as I figure out how to get out of Google Groups, if anyone knows, talk to me. But I'm not sure how to get the archive out.
So one of the things we're really wondering about is whether or not we should create an OpenZFS foundation. Obviously, Justin and others have had experience in doing this. I don't know how much work it is, but it seems like having the ability to transfer ownership of the logo as well as the domain names and just kind of being a resource for people to show their support through donations and do these kinds of things separate from any company would be a good idea. I know that, Brian, you've mentioned that people have come to you and said, how do I give money? And we can create an OpenZFS PayPal, we can have people PayPal to Matt, but I'm guessing that people would feel more comfortable if there was actually a foundation there.
I'm not sure Matt would feel more comfortable.
So one of the questions is like, if we create a foundation, what should it do? Like, what should the point of it be?
Yeah, we definitely.
I had a question on the trademark.
Sure.
At one point, Oracle had abandoned the ZFS, but they've actually since reapplied. And I was curious to see how that would affect. If they are able to reattain the ZFS trademark, would that not preclude them from using it?
I think that they did get the ZFS trademark. I don't think that it would necessarily preclude us from getting OpenZFS. I think that's something that we would need to basically try and apply for it and hope that it works out.
Yeah. And if not, like
I think there's other instances of people getting trademarks for open whatever.
Yeah. Right.
It may be that maybe we can't get a trademark on the word OpenZFS, but I'm sure we can get a trademark on the logo, like
the word
the logo plus word.
Yeah.
Agreed.
So
I didn't know if you approached Oracle and actually asked.
No.
Getting high enough into anybody who can actually make a decision on that, like basically is like.
I think we kind of assume what the answer is going to be.
Yeah.
Right. Also, I don't know that we want to really call attention to ourselves with them.
So having a foundation is I'm not part of the previous foundation. Justin is, who's hiring on this laptop.
Yeah.
But from an outside perspective, it's been really a big boon to the previous team. It gives places for vendors to ultimately chip in on the feature done. It lets us grants legitimacy to it, which is always really important when trying to do open source. And we've actually, this last year, we can fund those people. It seems like a good idea. Maybe Justin wants to.
Well, give you a little background, I guess, on the FreeBSD Foundation. It started in 2000. It took a really long time to get to the point where it is right now. So just have a lot of patience. Mostly because the people behind foundations like this are very passionate people that want to have it happen, but they also have day jobs and families and all these other commitments as well. And at least to start, at least the way the foundation was, the FreeBSD Foundation was, for the first 6 years or so, we had nobody that was paid, right? Before we had enough of a financial footing where we could say, okay, we think we can go to that next step of our evolution. And so we hired a part-time person, and then it was just on and on and on. But I think the other aspect of having a foundation that's really beneficial, at least has been for FreeBSD, is that in the corporate world, it's still very hard. It seems like it shouldn't be now. It's like we've had 30 years of open source, right? Corporations should understand how to talk with open source communities, but they just don't understand it. And so the FreeBSD Foundation actually spends quite a bit of time going in and talking to corporations about their use of open source and how to interact with the community properly and make the best use of open source. And those conversations, I think, are extremely valuable, at least for the FreeBSD community. And we take the information that we learn from those meetings and then funnel it back through developer meetings and back into our community, and that actually turns into the roadmap for FreeBSD. So it's just another avenue for getting a very important feedback about what the open source community should do.
Well, there's some overhead, obviously, with foundations, right? Because you've got to have
Yes.
a structure, and you've got to have minutes that get published, with like all kinds of like.
That's actually not so bad. So when I started the foundation, you have to have 3 people, at least if you're a US one, right? You have to have a secretary, a vice president, or president, right? And so I was the secretary. I said, I'll take care of all the paperwork. And the paperwork, as far as getting the nonprofit status, that's difficult, hire a lawyer.
Yeah.
The other stuff though is not so onerous, really. That shouldn't be the part that scares you away from it. And I mean, our nonprofit process was maybe $5,000. So it wasn't a huge investment to be able to get to the point where we were a 501c3. But as far as overhead, I mean, the open source community has to understand that if you're going to hire people to do stuff that the community is doing and things like that, they have to accept that there will be some overhead that won't be directly going back into development. It might be going into sponsoring events like this, or outreach, or marketing, and things like that. And so one of the things that the FreeBSD Foundation is working on right now is we're again at another one of these transitions of a step function in our capabilities. But our overhead, probably the way that we would account it right now, is maybe 25%. But we have enough staff on hand that if we were able to double or triple our donation level, our income, our revenue, that we could probably keep the same staff and drastically reduce our overhead. But you run into these places in your history as a foundation where your overhead is going to be higher than you'd like, and you really need to then go out and get more revenue and really work it so that you can balance things out again. It's this constant cycle.
So what, I mean, when we all work for like companies that would hopefully support a OpenZFS foundation, like what would be compelling about that to solicit your companies? Like, what would you be looking for? Is it, development effort? Is it like, should we target, like, we should, fund somebody part-time to go work on like making all the make files and doing all this stuff for the code repo that, is kind of grunt work that is unglamorous? Or should it be purely like an advocacy thing where, the foundation sponsors events like this, and we have a booth at other conferences? Or
so again, just speaking because I think that you could draw 100 different parallels between what you want to do with OpenZFS and the FreeBSD Foundation. Most of the folks that we talk with, they're really interested in about 4 different things. The first is, will it be there, right? That's a big issue for people. It's like, I'm building a product or a service that depends on this,
I know that technology is going to change over time. I can't do all that development myself. How do I make sure that 4 years from now, I'm not in a dead-end product? That's something that the foundation could speak to. The next thing that they talk about, talking with commercial users, is what are you working on, right? So can I fund a specific development project? But I think that's actually not nearly as important as the ability to improve the downstream experience of people who integrate the technology. So that's probably the third thing that these guys are concerned about when you talk to a commercial consumer. What is your test environment? How do I get fixes back into your community? How do I know that the regression that I fixed doesn't come back again in the future? What's your testing methodology? All of those things about making it a professionally developed piece of software that you can rely on. So I think that's also a very important thing that you can speak to. And then it's just about, at least in the FreeBSD case, being able to grow the community so that there are people to hire. So sometimes it's talking about training materials, so that once I've hired somebody, how do I bring them up on this code base? How do I make them effective? How do I then get them into your community, right? So that our changes don't stay here and we have to maintain them over time. So it's really those four things. And I think that as a foundation, you can speak to all of them very, very well. And it's a single point of contact for these people, right? So they don't understand how to talk to 100 different developers and get what they want. They can talk to you and say, oh, well, you happen to be having a problem with fragmentation here. Well, George over here, is the person to talk to. And by the way, have you integrated this change set, whatever. And that provides extreme value to companies when you go and talk to them. So almost all of our discussions when the FreeBSD Foundation goes and talks to a consumer of FreeBSD, it's not about money. Because oftentimes that's the barrier to actually getting in and having that conversation, is they think that you're just going to come and ask for money. The entire conversation is about facilitating their use of open source. And so by phrasing it that way, we're able to talk to the people who can really make a difference for that company, as well as for our community. So we have conversations with very high-level vice presidents, sometimes CEOs, talking about the business model of how you integrate open source. And that really does have a big value add for people to support the foundation.
Cool. That's super valuable. Does anyone else have some experience dealing with foundations, either on the creating them side or interacting with other foundations?
Well, I mean, sorry, we were really surprised at the fundraising we've done. I mean, just in the foundation has done over the past couple of years. I think with the ZFS being on Linux, there might be some really deep pockets to fund a lot of the things from external sources. And it also seems to function as escrow almost, for when you do want something. So if you do want all the make files done, everyone's like, well, maybe someone else will pay for it. But if Delphix, if IX, a bunch of people all put money in a pot, then we know it's going to get done. Doing that outside of without a foundation entity is pretty challenging, and a lot of paperwork and really frustrating. So that's what I wanted to add.
As many of you probably know, we failed to have an Illumos Foundation. I am still trying with the state of California to wind down the Illumos Corporation. One thing we found out is that the nature of Illumos is such that it does not qualify as a 501c3 because it is development towards the commercial profit of one or more entities. So we were trying to get it done as a 501c6, which is essentially a trade association. It's not exactly the same, and I have a feeling that might happen in this case.
Do you know how they make that differentiation? Because on the service level, it seems like FreeBSD and Illumos are kind of very similar in terms of their goals. I mean, lots of people use FreeBSD in commercial products.
Right. So the way that the FreeBSD Foundation was created was towards research and education, right? Using it as a platform for that. And so that's how we achieved our 501c3.
And also it may have something to do with timing, because I'm told that the IRS has cracked down a lot on 501c3 status. So it can get very messy and complicated. And also the overheads, you've got a kind of chicken and egg problem that you get to a point where you need at least part-time staff to do certain things, such as ask for funding, but you don't have the funding to pay the staff without, etc. I would also have a look, there were some interesting talks at the Community Leadership Summit, which takes place before OSCON every year now for the last 5 years. Henrik Ingo, formerly of MySQL, gave an interesting series of statistics he'd pulled together on whether open source projects really need a foundation or benefit from it. And his findings were pretty much came down to no. So I would think long and hard about whether to go down that path. It may be worth it, it may not, but things are changing very rapidly in this space, and it's not as obvious as it used to be.
Check that out. If there are people who would like to help with a foundation, if we go down that path, please raise your hands now or send me some email. No, there's someone else.
There's a couple others.
Cool.
Yeah.
So moving on to the next thing, do we need community management? I mean, we don't have a community manager. I mean, I don't know. It doesn't seem like we do. We've got the developer mailing list that, you all just kind of contribute to.
There I have the good side of the coin is that SmartOS and Illumos have not really needed much management, and we have all specifically avoided the governance orgy that was open Solaris. So we've had a couple of blow-ups on some of the mailing lists in which people just went nuts and went off into politics or what have you and had to be suppressed. So I think there's enough consensus around these as groups of technologists that, it's like, basically you are kind of the head of this whether you want to be or not. And so if you stepped in and said, hey, this has gone too far, people would accept that. So it may be that there's not that much formal process needed.
Plus, you have the admin passwords.
It's challenging to impose moderation on lists when you're not moderating, and it causes problems. So I mean, sometimes from our dinner discussion last night, it seems like there may be some chatter on the list that is distracting and can confuse people who are coming in to contribute. And we face the same thing in FreeBSD and FreeNAS too. So sometimes it might make sense to have posting guidelines, some kind of moderation to it. That's it. We mostly live without it, but the fallout is what it is. It's, we get someone who really wants to contribute gets flamed by some nut job, and it's painful. So it's something to think about.
So one other thing on the community management thing, because FreeBSD's been around for a while, and I think we've gone through periods where we had better internal management, and cases where we just didn't have very much at all. Community management can, if you're just talking about like list moderation, stuff like that, that's probably not as interesting, at least from my perspective. But what is interesting is strategic planning, better tools for accounting, what people are working on and where it is and what its state is, and maybe by using GitHub and people having their work pushed up there, that'll take care of some of it. But oftentimes, during these periods where we had less management coming from like the FreeBSD core team or what have you, there lacked focus, right? What are we trying to achieve in the next 6 months, or what are we trying to? What is OpenZFS supposed to be really good at, and what are the spaces that we're not interested in, right? That kind of level of definition, which doesn't necessarily come from just one person or one group, but having it recorded somewhere and making it so that it's not just a couple people who have to constantly remind people on the mailing list, that's not what OpenZFS means, or we really need to finish this feature because that's our goal for the next 6 months or whatever.
Mm-hmm.
So what other areas of focus we want to have? Maybe this is probably too long a discussion to have right now, but something to think about is, we've talked a lot about the development projects and the ways in which we want everybody to come together. Are there other things that we want this community to be about? we've seen on the mailing list where people will come up and they're new users and they want to know more about just CFS as a whole. So we've tried to do a little bit in terms of writing architecture documents and that kind of thing. But are there other areas that we want to expand to try to promote OpenZFS further? Nothing springs to mind. Anything else we want from community management? More dev summits?
I mean, we talked about testing methodology, or that was mentioned, but I would just underscore that one of the main things I would want to see is infrastructure for, builders, automated continuous integration testing.
Right, something that's cross-platform as well.
Yeah, because I don't see the shared repo or common code base being viable long-term unless we get to that point where we're doing automated builds and testing on all platforms. So I would hope that would be a focus.
I like the suggestion someone had earlier, though, of like, if you care about a specific platform, provide the hardware to test on it.
Yeah.
And so if there's some sort of infrastructure where you can plug in your VM.
Yeah. It's not just hardware, though. It's like
it's all the
software. Yeah.
Getting someone to pay for a VM in the cloud is easy. They just like say, hey, you paid this much amount per month, and that's part of your donation that goes to cover those bills. But getting all the infrastructure, so you can actually spin those up. Which
I'll buy a
distribution
VM for a month. How do I use it? Like, that's the hard part.
And running a hardware lab is even harder.
Yeah.
Right.
That's
I have an interesting side effect that my users seem to expect user interfaces.
What?
Have we considered a platform-independent user interface? Something like that, where it actually would work for everyone.
OpenZFS.
Well, more of a WYSIWYG. What you see is where you get sort of buttons to create a pool and all that. I mean, I looked at ZFS Guru, but it's PHP and it was not as easy to get running on OS X, perhaps.
Wait, you would like a GUI for managing it?
I don't, but a lot of my users do.
Yeah, FreeNAS. Grab it. It's BSD licensed. You can do whatever.
Yeah, so okay. That could be an option. Get it run on OS X.
The other kind of things that might be worthwhile is resurrecting the old ZFS administration guides, getting them updated to match reality up there. In one centralized location for that kind of documentation. Trying to deal with all the platform differences in one spot, kind of just in terms of just making how to find information about how to do basic things.
And all of you guys are going to sign up for office hours? Yes?
So we did the one office hours. Like, are people interested in seeing more of those? And then also, are people interested in hosting or being the moderator? Who wants to see more of these or thinks that they're valuable for the community? All right, a few people. I know a few people have already volunteered, but any more volunteers to host and answer questions? And
I could probably sign up a couple of people from joining for you after the turn of the year.
Cool. All right. Yeah, I think that's definitely a good activity to continue.
I really love that format, by the way.
Oh, thanks.
Find out how you do that.
Yeah, it worked really well, I thought. It was Google plus Hangouts on Air. It like streams live to YouTube. So like anybody that can use YouTube can view it. And then we had people like ask questions either by joining the Google plus Hangout or by doing it on IRC. And I just repeat that. So, I mean, part of my question is like, I think a lot of these are really good ideas, like updating the admin guide and creating this foundation and making makefiles, but
I don't let him have time to do that.
Yeah. So how should we go about finding people to do this? Should I be going and posting on the mailing list and saying like these are the priorities that we gathered from the development summit, like who will do them, and then hoping that somebody like volunteers, or like should I be going and like finding particular people and being like, hey Max, you want to do this, don't you? Come on.
I think that you should talk about it before handing people beers tonight. I think we should like have that person ready to get a drink. Yeah, it's really good beer.
We can tier the beers.
Yes, we can tier the beers for your contribution.
So I think one thing that might help you there is by lowering the barrier of entry. So when we're talking about all these documents, right now there are these monolithic PDFs and, trying to understand, well, can we use any of that material? Or we have to write it from scratch? What material can we do, right? And then bootstrapping, finding just a couple people who can just bootstrap it. As in, take whatever content is available, get it in some place that has easy access, and then you can go to the community and say, hey, maybe you know something about a particular section of the document. You can just go in there and edit it, more wiki style than formal PDF documents.
It makes sense.
I know in some cases there are a limited number of people who can actually write specific documentation for Illumos or MaxZFS.
How would one go about changing that stuff?
So-
Like the on this format document is old, and like if I go and study it and I work on this format for a month, and I'm like, okay, now I understand. I could probably modify it.
But it's just a PDF.
But I don't know how that
So what
would
we
do
did,
it.
so for all the old Sun documents, for example, we actually still have all of them. So they're in kind of crappy format since it's solo, a lot of XML. But we have a license that lets us do whatever we want with them. So like we've been slowly converting them for Illumos, but we have the ZFS one. So it's just a matter of just like going through, cleaning it up, like changing references to names and just like dealing with a few markup things, and then there you go. It's easy to go build and put it on a website. So they're just sitting around. So for those, it's kind of easier. I'd say for a lot of those things like the on disk format, you're better off just
copy paste.
Just copy and paste, like just do some like markdown file or something like that, and just like something that's simpler, just kind of go and edit and.
But where's the upstream document?
Well, then we'll just create some PDF. Just create some repository that basically has formal documents.
Right, it just needs to happen, right?
Sure, yeah.
So you either just create like a web page on the wiki that exists today, or like create a GitHub repo that has your markers or whatever source you're going to use checked into it, and then have some way of building that and then putting it on the web page.
Yeah, and there's definitely stuff that we can get added to the website as well. I mean, Luke has talked about possibly setting up some additional things. Like we asked for OpenGrok to be out there, which hasn't happened yet. And they're obviously limited in their resources as well. But if there are things that we want to see added, definitely send me the list and we'll ask. Anything else? Cool.
Cool. All right. Thanks, Karyn. So next, Chris and Max, can you tell us about ZFS channel programs and why we're going to put Lua into the kernel?
Yeah. Can't even get a super computer there.
Yeah, everybody has to have Lua in the kernel.
Yes.
Put it on my to-do list. No, it doesn't need to be on your to-do list because these guys are going to do it.
Oh, we Linux for all
Linux. The porting layer interface can be underneath Lua, and then you can just take Lua, and it'll use all the ZK.
Yeah.
Underscore things. This Lua thing is like as of Friday, so although it didn't work. So this is an idea Max, Matt, and I have been throwing around for months now, right?
Yeah. Well, not the Lua thing, but the channel.
Yeah, the Lua thing is as of Friday. Before that, we were going to write our own bytecode and parser and lexer, so that was a bad idea.
So this are improving?
You want to go back to the beginning of the presentation? Okay, cool.
Yeah, can you guys introduce yourselves?
Oh yes. So I'm Chris. I work at Delphix.
I'm Max. I work at Delphix too.
So
Chris implemented a lot of the feature flag stuff. So we have him to thank for that. And Max has recently worked on a project that is not yet integrated, but do you want a few words on the whole Earth?
Yeah, so I started Delphix about 5 months ago, and one of the first things I worked on was whole birth, which basically when you do a ZFS send, it sends things called free records, which represent holes in a file where it's basically all zeros. So we don't actually have to allocate space on disk for these holes because they're zeros. We can just pretend we actually wrote them disk. But when you do a ZFS send, if you have very holy files, very holy data sets, you're sending a lot of these free records, which takes up a lot of
takes up a lot of bandwidth and makes your send streams take a long time. And so I did some work on changing the behavior of the birth times and basically recording when things are freed so that we don't need to do these sends of redundant free blocks if the target of the send is already aware that those blocks are free.
So we were to do this for data blocks, like don't send things that are older in an incremental send, don't send things that are older than the originating snapshot of your send. But we never recorded when we freed blocks, we didn't record what transaction the block was freed in, so anytime you saw a freed record, you had to send it, which caused problems. If you have like a zvol with some other formatted file system on top of it, for example, you'd have lots of free records, and every time you did an incremental, you'd have to send all the free records.
So this adds the birth time. So now the polls now have birth times, and we can figure out exactly which ones need to be sent. Anyways, which is unrelated to channel partners, but just so you know who these guys are.
All right, so I'm going to talk a bit about the problem, and then Max will talk about Lua.
Which I learned yesterday.
All right, so a little bit of background before we get into the problem. Just when you run a ZFS administrative command, so this is things like that manipulate the ZFS level metadata, like creating new file systems or setting properties or creating snapshots. These operations are done in what's called sync tasks. And the idea is we do these, when you run one of these commands, we send a ZFS ioctl to the kernel. It says, I want you to create a new file system with this name. And the kernel will queue that operation to happen at the end of the current transaction, or at the end of a transaction. So the idea is at the end of each transaction group, we hold all the locks, say no metadata updates, and a single thread goes through and has kind of the power to update all the metadata, create new file systems, take snapshots and stuff. And then so this ioctl waits for the current transaction to complete so that you know that this update happened, that you created the file system and the snapshot was created. So this creates a problem because transactions don't happen that often, and it scales based on the load of the system. So in general, I think the target was like to do it at once every second. Yeah. Right? But if you're on a heavily loaded system, because the idea is in order to finish the transaction, all the dirty data has to be on disk. So if you have if you have lots of data all the time, it takes more than 1 second to sync it out, and so the IO throttle kind of scales our target to say like, okay, so we've got a system at Delphix where each TXT is about 10 seconds, I think. And so this means that each time you do an administrative operation, you do the ioctl down to the kernel, it puts it in the queue to be finished, 10 seconds from now, basically. And so on our system where we have store our VMs, we have kind of some Python scripts that use ZFS properties and metadata and does a lot of destroys and promotes underneath the hood, but each of those is one operation. So we send down like a command to do a destroy, and then we wait 10 seconds, and then we send down a command to do like a snapshot and takes 10 seconds. So each command the user runs, like create me a new VM, could take a minute because it had to do 6 administrative operations. And sometimes you can do them in parallel, but sometimes you can't destroy the file system until you've destroyed the snapshot or something like that. So you can't actually send the commands down in parallel. So that's problem number 1 is just how long that takes. So as the system gets more full, these administrative operations, you start noticing how long they take. Another problem is that within these sync tasks, so if you say take a snapshot, we do a lot of checks. So I was saying earlier, during this sync task, we hold all the locks, we don't let any other threads update the ZFS metadata, so that we can consistently check, if we're taking this snapshot, we can check that the file system you're trying to take a snapshot of exists, and between that check and the time you actually create the snapshot, nobody else can modify the metadata. So this works within the sync task, but now if you're splitting across multiple operations, say you want to do a destroy, but you have to do a promote first because there's some clone of this file system. You'll do the promote in one sync task, and then 10 seconds later you'll do the destroy, and between those 2 points someone will have created another clone, and that won't work. So you and there's a lot of logic, for example, ZFS destroy-r, which destroys all the snapshots of a file system and then destroys the file system. It's actually, first it gathers the list of snapshots in userland, which hopefully isn't changing because it had no locks held when it gathered the list. Then it sends that list to the kernel, and in one transaction destroys the snapshot, and then does a second transaction to destroy the file system. So the system crashes between transactions, or things are changing too much. So you get, well, we try to have good results, but there's a lot of complicated logic in user land to ensure that we have the right results for some of these weird things. Just because we have very specific things we can do transactionally in the kernel, defined in these sync tasks, and everything else we have to kind of wire together and worry about in user land and worry about different transactions. So all the different snapshot dash capital R is even worse. I don't know how many transactions that does, but it's a lot. Let's see. And the last problem is we've been adding more and more features, or Matt's been adding more and more features, like the taking snap. I think you added this in the last year or so, like taking snapshots, giving a list of different file systems to take a snapshot of, rather than only being able to take recursively under a single point. But each time we add, so ZFS destroy-p and rollback-p are like on my wish list, and then there's and the idea is like destroy-p would atomically do the promote and then destroy in a single TXG to avoid that problem I was talking about earlier. Rollback would do a similar thing. If you want to roll back through a clone, do the promotes to make the rollback work.
And every new functionality that we add, like the bookmarks stuff that I was mentioning earlier, like you want to be able to create a bunch of bookmarks at once or destroy a bunch of bookmarks at once and all that stuff. Like you got to go re-implement a bunch of boilerplate stuff that Snapshot also has to do and destroy also has to do.
So you end up, for each new feature, you end up with this trade-off. Either you do it, tie it all together in user land and have really complicated code to deal with transactions, like the fact that not everything's happening transactionally, or you write this terrifyingly long, giant sync task function in the kernel and hope that nothing's wrong or everything will explode. So those are the problems. Max will now talk about the solution.
So our solution is called ZFS channel programs. And basically, a high-level idea is we want to send a stream of instructions that execute down to the kernel and have ZFS execute them all in syncing context. So, for instance, this could be executing multiple snapshots, destroys, creates, and kind of force the ZFS kernel module to execute these all in syncing context, which means you get that atomicity, you get better performance because you don't have multiple transactions, things like that. So yeah, like I said, you get atomicity, you get consistent state. You don't see, some weird state where half of your snapshots had been destroyed, but not the other half. And you also get more rapid development of new sync tasks, so you can quickly prototype up some new combination of these different intrinsics like snapshot and delete and create. And rather than having to, create this entirely new sync task in C, you can just write it quickly in this scripting language, have that be translated into this stream of instructions, and send it down to the kernel, where it'll kind of interpret it like an actual program. And so this will be a lot faster and a lot more fun than the way it works now.
I think that'll be really cool because creating a new, even if you've already written the sync task part of it, creating all the infrastructure around that is there's 7 layers, and you gotta add a new ZFS subcommand. You gotta figure out how to parse the arguments. You gotta plumb it through libzfs, libzfs core, then the IOPTL layer. The sync task layer, that could be 30 lines of code. Right. But then you've got another 100 lines sprinkled out throughout all the different layers of the stack, just to do one little thing that should be simple.
And the other cool thing about this is it's a single IOPTL. So in terms of, I think it's like compatibility across platforms, is you only have to support a single IOPTL, and the kernel can decide, what intrinsics it supports, and maybe throw back an error if you ask for something that it doesn't provide.
So this is particularly around the user to kernel interface stability, which is an issue on Linux and FreeBSD where you try to maintain a stable kernel interface. This should help with that.
And a couple people had mentioned asking for a better programmatic interface, and this would be a better programmatic interface, especially if we're glossing over a lot of details, but it'd be nice to have a way to, for example, return data from this, not necessarily from syncing context. So if you want,
with all the locks held. With the locks held for reader.
Yeah.
Yeah. You come down to the kernel, you get the
and then you can say gather your SQL status,
your data,
and you can form the object that you want, and it comes back as some env list that's correctly formatted in the way you expect, and you get to write your program to do it the way you want.
This also simplifies all the error code paths we have today, which are
because you can reduce the number of possible errors by using this.
And then any existing functionality, of course, would basically just be translated into a constant string of instructions. And so for any of the existing commands, ZFS commands or apples, is just send this constant string of instructions that we have pre-generated or whatever. It's easy to port. So just to make it more concrete, this is a simple example channel program. So ZFS destroy-r, you destroy all the snapshots of a file system, then destroy the file system itself. So the way this works today, like Chris mentioned, is you list all the snapshots of a file system, you issue a destroy on all those snapshots, and then you destroy the file system target itself. So you could write a simple script instead that has nice scripting. This is Lua, similar to Python, so if you don't want, you can probably learn the other. And you just iterate with a nice for loop. You do a destroy of each snapshot, and then you do a destroy of the target. And so all of this gets executed in a single syncing context. It's faster, it's more correct, and the host application doesn't have to worry about kind of working its way around any weird edge cases where you can get into inconsistencies or failures halfway through a long sequence of interconnected operations.
So maybe you're going to address this later, but do you want to talk about, like, let's say one of these snapshots can't be destroyed for some reason, right? Like it has clones. Then how would that error be handled? Could I still end up with something where it's like some of them are destroyed and some of them aren't?
So I think what we're thinking, and you can definitely chime in here.
We haven't translated that part of the Lua yet. That's the problem. We had a plan for this earlier, but
I mean, what the way syncing, something we didn't really mention is what sync paths do now is they have a check function and a sync function. And so the check function makes sure that this operation can complete, and then the sync function actually completes the operation. And so I think what we kind of try to do with here is have a sort of a dry run.
I think the important thing is you can run a bunch of, within some constraints, you can run a bunch of check functions, and that guarantees that if you run the same sync functions of all the check functions you just ran, all of them should complete properly. So you can kind of do a dry run ahead of time to make sure it'll...
Like for this, you could do a dry run, and then the dry run would guarantee that it all works or all fails.
Right. So in this, as he's drawn it here, I think this would actually, like, if it fails to destroy a particular snapshot, you wouldn't, it would destroy the rest, but not destroy that one snapshot. But I think the idea is you would wrap, so Lua has first class functions, you would have some function like dry run then do, or with a better name, and you would wrap this in that. And so it would, for each snapshot in this, it would run the code once with just doing the check functions, and then if all the check functions pass, it would run the second time running all of the actually doing the work. And so since the check functions all passed, you'd be guaranteed that all the actual functions themselves would pass.
I think the cool thing about this is that it puts that kind of semantics into the control of the application. So the application can, can think about, application writer can think about like, how am I going to be able to check these? What do I want the error semantics to be? Do I want it to just like do as many as it can, and if it finds one that it can't do, then just drive on? Maybe that's the right.
Yeah, and because right now we have some weird things like on when you do this list of snapshots, we just kind of made up a definition of like, if the snapshot fails to be destroyed
because it's end,
because of a certain error, then go ahead and finish the rest of them. Oh yeah, because it's end, because that means it already doesn't exist, and then return an env list of all the errors. Here you'd be able to say like, check the error, like if you cared about errors, you'd be able to actually define that here and then like form some output object that would contain the errors that you cared about, rather than having like whatever Matt arbitrarily decided would be the best, according to him, to be like what everyone has to use. Which, I mean, for snapshots, I think that's not as big a deal, but when you get into like I want ZFS destroy-p that takes care of the promotes, then there's like, oh, well, or ZFS
one to promote.
Yeah, I think one of the other feature requests that we had that we wanted for our VM system was like recursive destroy that does deferred destroys, except that exists. There was some combination of like mixing, where you end up with like 20 different flags basically that you have to interpret, or you can just write a program that says what you want to do.
So we have to implement the infrastructure for interpreting the program.
Yeah.
So this is kind of a high level. So we chose, what we want to do is we want to basically add a Lua interpreter to the kernel that'll take these streams of instructions that are passed down from user space and actually execute them. So the great thing about Lua is it's designed as a domain-specific language. So we think it's going to be easy to add these kind of CFS-specific language library features to it and have the Lua interpreter call back into the CFS functions that are actually implementing the logic. And so, for instance, this would allow for that dry run capability because we can basically ask the ZFS interpreter to execute these instructions with a dry run flag set so that we know we don't actually want to make any changes, and then go back, have the dry run flag or the dry run off and actually run everything. So we're kind of still sorting out exactly how long it's going to take and what the first steps are, but we're definitely
the first step. I made Lua compile in the Lumos kernel.
Yeah, it compiles.
It compiles, so it works clearly.
Yeah, that's.
So, what is your plan of action in terms of tomorrow?
Oh, we're gonna work on this tomorrow. I think. Are you working on this tomorrow?
Yeah, we're working.
All right.
So
we can take another person too.
And what do you aim to get done tomorrow? Like, what part of this?
Well, I started hooking up the compiled Lua in the kernel to the IACWL interface. So I think it'd be nice if we could execute something in the kernel. Either something that just takes snapshots or can list properties. Basically have something we can demo at the end of the day where like I type something in, or we type something in and then something comes out.
Send some instruction stream.
It creates a snapshot, or it creates a file system, or it outputs some string to the debug log, or something.
Yeah,
scale it according to expectations.
Do all this for a debug log printer.
It could be that as soon as we pass something into Lua, that I compile it to the kernel attacks. So,
I mean, do people think that this is is this a problem that other people have, and B, the solution?
As opposed to another language.
because it's a relatively tiny, very highly functional language that's meant to be embedded in things, as opposed to every other language that exists.
Yeah, there's a follow-up on that. How do we deal with Lua's a pretty floating point heavy language?
Nope. You can you can reconfigure all things in Lua. So you can reconfigure how they parse numbers, how they do arithmetic. So you can. When I made it compile in the kernel, I removed all the floating point stuff.
Yeah.
You can actually the Lua number. Yeah, the Lua. There's actually a pound defined Lua number type that is double, and you can change it to int 64.
Is there a way to do this without needing a whole language inside the kernel?
Well, that's kind of the point, right?
You need some kind of language in VM, whether that's
right.
or something else.
So before Friday, our plan was we're going to make some NV list format that the kernel will parse that will let it interpret. And it was basically we just had all these artificial restrictions based on how much of an interpreter we wanted to write ourselves. So we figured, why not just take an existing interpreter that works and poured it into the kernel, which was, I did it in an afternoon. So it's very much meant for this type of thing, not quite into kernels. But in
a sense, you're just you're saying, you're adding all this logic that you execute in the program, and you're just saying, do this, then do this, then do this. If this happens, then do that.
Yeah.
Can't you just queue up all those operations in user space and just pass in a list to the kernel?
No, because what you want to do is be able to check the state of things. You want to also be able to look at the data. So
if you say, for
I guess.
you say, if this is true, then do this.
One of the examples
in userland, you only know you can do that in userland. You can say, if this is true, then do this. But by the time you do this,
it may not
the predicate may not be true.
So, for example,
because you have to wait for the sync.
Well, because you had no locks held.
Yeah, we're doing it in a point where everything's.
So in this example, we do destroy -r right now, and it's kind of unless if you're creating and destroying snapshots as you run it, we did our best. There's a lot of logic in userland and a lot of thinking that went into what's the right semantics for this. But basically, you get your list without any locks held, and then you just send down a list of things to destroy. And if things have changed, then you might the second destroy might fail. Whereas here, listing of the snapshots is actually done in syncing context with the correct locks held. So you're guaranteed that when you like do the destroy, you actually destroyed all of the snapshots.
I'm just thinking in terms of dealing with the Linux kernel community.
Yeah.
Like, this doesn't seem like they would let this kind of thing fly. You know,
They also don't let ZFS fly. So
Right.
I'm not really that
So our goal was not let's put generic Lua into it. It's let's put Lua on top of the interfaces that, you know, this is what I was saying before. We should put Lua should anywhere. First of all, Lua barely has to call out into anything. You know, it has like one place where it does memory allocation that you can. That's once again like something you can configure. And that's, you know, pretty much it, and then it calls back into your stuff. So the idea is we put the ZFS interfaces. Lua is part of ZFS, not part of the generic kernel interface. We haven't fleshed this out completely, but to make it portable, it would be part. It would be part of. You know, when we create the open repository, it would be part of that. Our implementation, because like we were saying before, we're gonna like change it so it doesn't have to use floating points and stuff like that.
Or get prints.
Yeah.
Pretty standardized.
Yeah, I was just wondering, if you thought about how you're going to do safety, so like, I know if you think about like D and Gtrace, like, it makes sure that you basically can't infinite loop in probe context forever.
Yeah.
Like, if I do an infinite loop in my sync, like in syncing context.
Don't write bad programs. And also, well, so
I mean, seriously, like, I can't just say like, yeah, don't write a bad program. Like,
well, not anyone is gonna be allowed to run these things, right?
well, but if I have a delegated data set, for example, today, I can actually
Right.
delegate, you know, like doing a lot of these operations. So, you know, make sure, or channel, I guess, is the channel designed to be something we're actually going to be a first class abstraction to the user, or is it really just going to become an implementation detail of SBIN ZFS and SBIN ZFS?
So, I mean, my initial idea was that basically only root can send channel programs down. And then, like,
once root has defined them, other people can run them according to some permissions.
I mean, this is like just to be conservative, you know? So, like, these channel programs would be written, like, into SBIN zpool, and then, like, the kernel, like, when you boot up, like, root would send these down into the kernel, and then, like, when some ordinary user or somebody in the zone runs ZFS whatever, then it would, like, invoke the channel program that root had already fed down at boot time.
Okay.
So, like, in terms of like using the ZFS command line, like, it's just as safe as it is today.
Sure.
It's just that, like, those people in zones wouldn't be able to write these arbitrary programs and send them down to the kernel, so they don't get, like, as much of the benefit.
But they could if they were root, right?
Yeah.
It's just not.
Well, no.
Well, not in the zone, because
the container would basically, we know if you're in a container or not, so.
Yeah. Well, the idea is
Just in general,
this is
it's
done in
just-
syncing context, and so if you go into an infinite loop, you can stop all writes from happening.
Yeah.
I also had some other ideas about, like, you know, trying to detect, like, basically say, you can't go into an infinite loop. Like, you have to always
Solve
be
the halting problem.
Well, I mean, not necessarily infinite loop, but basically say, like, you can only run 10,000 Lua instructions before you actually, like, give us something to do, you know, and, you know, that prevents some of these, like, worst case scenarios. I don't know if that's really enough to let, like, ordinary people write these programs, but
Okay, I wasn't sure what the end goal of that is. So I feel like that end goal does inform the choice of language and design there.
I mean, I don't think that the end goal necessarily has to be for unprivileged users to be able to write these programs, because
But this would make it really easy to, for example, add a new ZFS destroy -p. As just a new thing that root feeds down into.
or, like, you know, when you're building your own management stack that's built on top of ZFS and you need it to do XYZ, you know, atomically, it lets you write that and just run that as root in the global zone.
Sure, yeah, I was just trying to think about it, because I know, like, I'd be terrified if I accidentally wrote a bug in that, and, like, it only comes up in some corner case, and that, like, all writes are gone until I basically panic the box.
Yeah.
Well, I'm sure we can have a way to cancel a running program. It's just that you won't be guaranteed. The problem is we don't want to, like, kill it arbitrarily after a certain amount of time, because
Sure, yeah,
some
yeah.
things
Oh, yeah.
have happened and some things haven't.
Oh, yeah.
But if you knew that that's what you were doing, if you were testing your code and you knew it was buggy, we could just let you say, like, oh,
I'm not worried about a bug in testing.
Yeah.
If it's a bug in testing, just remove the box. That's fine. No one cares except me. But when it's in production, then that means customer downtime. Or just, like, user pain. And that's just kind of yeah.
But I'm saying you don't have to reboot the box. Like, we wouldn't make it so that it hangs and you're lost forever. You have
It's
to
just, it hangs until the admin comes along and says,
And kills
oops,
it.
Kill it, yeah. And hopefully we can make this, well, other people.
Yeah, better question. So, you know, I understand that it runs in the context of that one transaction group, and I mean, it probably would. Is there a way to limit the time it takes to run it?
Yeah,
because if it delays the transaction group for a long time.
So,
on that side.
there's not a
it
really
just takes
great-
that long. Like, if you need that long to be correct, do you want to give up your correctness so that you don't have really long transaction groups?
Right. So it's
the same, the same problem exists today, where you can create you can tell the kernel, like, hey, I would like you to create these 10,000 snapshots. And it's like, well, that might actually make your transaction group take longer than is ideal. And then hopefully like the rate throttle will kick in and then everything will slow down gracefully, but eventually, you know, you could get some bad performance there. I think this is making it a little bit easier to get into those situations, but it isn't fundamentally different than what we have today.
It would be nice to be able to drop the locks and reacquire them. So if you know something that's going to take a long time, you do like a portion of it. Drop the locks, reacquire it, let it sync, and then revalidate your data. And
We could add a primitive
in the
that's
middle. I mean, you lose consistency immediately.
Yeah.
And
right, and then you have to rebuild that.
Be like a yield.
Yeah.
You can. I mean, but if you like destroy a snapshot, how can you rebuild that?
So I guess I would ask, do you have a specific example of something that you know can benefit from like this yield kind of primitive?
No, not.
I think it's something
Not
we could
all
add
time.
if there are things that could take advantage of that. It would be easy to add.
Back on the security perspective again, you know, are we going to put in mechanisms to prevent someone from blowing memory accidentally? Right, you say that Lua has to do memory allocation of the kernel, right?
Well, I mean, if we're only allowing root to do it,
I presume we can get Eno down at some point.
Well, I'm like, if we're only allowing root to do it, I suppose we could, you know, not worry about malicious users, maybe. But, you know, if someone, like, it might not be immediately obvious to someone that ZFS list or something would do lots of real.
Well, I
or how would
think
you
the ZFS list in this situation, hopefully, this is actually a bad example. We should have swapped it. But ZFS list presumably would be better in this case than the current case, because in the current case, you do need to read everything into memory. In this case, you could iterate
not
over
kernel memory.
No, not current. Well,
you don't have to have everything in kernel memory at the same time.
when you send down if you send down a request based on the list output, you do.
Yeah. But if you're just doing like literally ZFS list return.
But I'm talking like in this command, you do need to have all of the snapshots that you want to destroy in kernel memory.
I guess
Whereas
my point
you-
is more that there's some subtle things to pay attention to with running Lua code that include infinite loops and also.
I think that part of this is like we need to investigate like how you can debug this, right? Because you're talking about accidentally using too much memory. Those are things where we need to look into like how would you debug.
Yeah.
How do you have observability into what your Lua program is doing?
Dtrace's stack.
Yeah.
So show me what's going on.
Yeah.
Talk about doing like simulated event, like simulated user space and get some like usage statistics and then actually run the kernel or something.
No, we should have debuggability of this. There's a lot of steps. We should get it working first, and that's many steps away already, which is why we're kind of like, oh well, what about this? What if you accidentally do this or that? You know, it's what we get it working, and then we can worry about like making sure it's debuggable. It's not. None of those problems I think are insurmountable.
So to be clear, like this, all that exists is like Chris got Lua compiling in the kernel and like these slides. So this is very much a work in progress that we want people's input on. And
so it's beta.
But so it would seem there's a lot of parallels in terms of safety, except with the trace programs and this and that. I don't know, maybe you guys can leverage what is done for safety there.
Dtrace is very different.
It's a very different. The language has constraints. I mean, there's no backwards branching in the language, which is not the
we
case.
wouldn't want those here, would we? Or would we
Well, that's part of how Dtrace.
Okay, you want loops, right?
That's part of how
loops is kind of important.
You don't have loops.
Yeah, I mean, also Dtrace is running in different. I mean, dtrace is running in like the most constrained environment possible. Like you cannot allocate memory, you cannot take locks, right? Versus here, like we're in the loosest, one of the loosest kernel contexts where like we can allocate space and we can take locks and like all this kind of stuff. So, I mean, it would be cool if you could write your dtrace in Lua too, but that's a lot trickier than doing this project.
D++.
Other concerns or flat out criticisms, or this is useless, or it needs to have X to be legit. We are kind of gathering requirements here, so.
I think it's an awesome thing to build on just in general. I mean, you wind up with, I've done some performance work for other products, and the request has been, can you help us avoid the context switch between user and kernel often? So just like getting a chain system calls together is actually really, really nice. We also provide some primitives that help with some sort of copy stuff. People like doing some things like, almost like send file patterns, right? Like almost writing send file without something. It's pretty cool.
Cool. All right. Thanks, guys.